That's it. That's it. That's it.
Just a little more chatty than I like, which means please stop being more chatty. Because Mrs. Nolan has a huge announcement for you. Mrs. Nolan. Connor Morgan, he's here. Did you ask him to? Many times? Okay, under fractions, please, jot this down here. People are a lot of times afraid of fractions, I guess, rightly so, but that doesn't matter. A fraction looks something like this. And we're going to give you the names of these things. On the top of a fraction is what's called the numerator. So write that down because I will ask you those things. The bottom of a fraction is called the denominator. And this little thing here we call the fraction line. And with that being said, when you have a fraction, okay, the denominator is the number of equal parts you cut something into. And the top number, the numerator, is how many of those parts you're talking about. How many of those parts you're talking about. So, for example, by the way, well, that's not. Let's say, you know, the old common, if you ate 1/2 of a pizza, basically that just means this. You've got your pepperoni, sausage, whatever pizza you have there. I like to use pizza as an example. Half, the bottom number says that I'm taking my one whole pizza, I am cutting it into 2 equal pieces, and again we can only draw so equally here. And since I'm only talking about half of the pizza, I only have 1 of the 2 pieces. This is what 1/2 of the pizza would be. If it was 3/4 of a pizza, still start with my same pizza, but now I'm cutting it into how many equal pieces? 4. So as best I can, I'm going to split this into 4 equal pieces. Circles only work really well when we do by 2s, 4s, even numbers. And the top number is how many of those 4 pieces I'm talking about. Well, here's 1, here's 2, and here's 3. 3/4 of a pizza would mean you cut that pizza into 4 equal pieces, and you have 3 of them. You might need this in there, or maybe in there. So that's the whole fraction thing. Now, here's a problem from the book. Let's write this one problem down, and then we'll get to your scissors here in a bit. There were 20 pumpkins in the garden. There were 20 pumpkins in the garden. 1/4 were too small. 1/10 were too large. 1/2 were just right. And the rest were not yet right. The rest, not right. And the question I'm going to ask you is, how many too small, how many too large, how many just right, and how many not right? Now, anytime you come up with a fraction story problem in your math, you are going to sketch it out. I know that's hard for you to believe that I would ask you to do that. I will tell you exactly what I need to see. Here is what I need to see. You're going to draw I know fractions people like to draw circles, but we're going to actually draw rectangles for our fractions. Okay, so for this first one, to find out how many were too small, I draw a rectangle. Okay. What does this rectangle stand for? This rectangle stands for all of my pumpkins. All 20 pumpkins. Okay. All 20 are there. And I'm looking at this fraction for the first one, 1/4. Well, remember, I said the bottom number of fractions stands for how many equal pieces I cut that into. So I'm taking my pumpkins, my little rectangular box, and I'm cutting it into 4 equal pieces. So I do this, cut half, there, 4 equal pieces. Are you with me so far? If I cut 20 into 4 equal pieces, how many pumpkins would be in each group? If you take 20 and divide it into 4 pieces, here's our division. Chase, everyone's going to have
5.
Right, so each one of these fourths is 5 pumpkins. 5 pumpkins, 5 pumpkins, 5 pumpkins. Okay? And the top tells me how many of those pieces I have. I only have 1 of them. So, how many pumpkins were too small? 1 out of the 4 pieces or groups, which is how many pumpkins? Ellen? Right. 5 pumpkins were too small. Now, unfortunately, to figure out how many were too large, it's a different fraction, so I can't use this same rectangle. I got to draw a whole new rectangle. Still looks kind of the same. Here's my big rectangle, except this time I'm using the fraction 1/10. Still stands for 20 pumpkins. How many equal pieces do I have to cut that box into? It's a little goofy, but it is 10. So if I do 10, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you take 20 pumpkins or 20 things and cut them into 10 equal groups, how many are in each group? Joseph?
10.
No. If I take 20 things and make 10 different piles of them, how many would be in each group? Zach?
2.
2. Every one of these groups has 2. 20 pumpkins cut up 10 different ways, you get 2 pumpkins. And only 1/10 were too large, so how many were too large? Just 1 of those 10 pieces, so how many were too large? 2 pumpkins were too large. Half of them were just right. So one more time I gotta go, I gotta draw another box for my half. Except this is nice because how many pieces do I have to cut it into?
2.
Just 2. And if you cut 20 into 2 pieces, each piece is 10. So half of 20 is? So 10 of them were just right. Now, it doesn't tell us what fraction were not right, but you have to assume that if these were too small, those were too large, and those were just right. Everything else, whatever's left over, has to be not right. So how many do I have altogether here? 10 plus 2 plus 5. 17 pumpkins we talked about. How many probably are not right? 3. You don't have to, this doesn't give me a fraction, so I don't have to do a fraction. I just have to draw my stuff down there. Isn't that exciting? Very exciting. Now, what we're doing today with your scissors and glue.
Yes.